So let's start with the friction. See, in our daily life, we come across many examples or many situations where we encounter friction. Those are the situations. For example, like if we kickstart a block, the block moves for a while and finally it ceases its motion. Why it happens? It happens because of friction. And consider another example. Suppose there is a huge block and we are pushing the block doesn't move, and it happens because of friction. Another example we can take, that it is easier to walk on the rough surface, but it is very difficult to walk over a smooth and oily marble surface, right? So these all are phenomena, these all are associated with friction. So let's talk about what is the friction. Friction is a force that opposes not just the relative motion but also the tendency of relative motion. We have seen in the example, when the block is given a kickstart, it moves for a while and finally it stops. And why it happens? Because the friction opposes the relative motion. In another example, we have seen that when we push a block, a huge block doesn't move. Why? Because friction opposes the tendency of relative motion. So because of that, the huge block doesn't move. And next thing we can note down about friction, that it is a contact force. It is a contact force. When two surfaces are in contact, the friction will act, and when the surfaces are not in contact, friction won't act. And next topic comes to our mind, what causes friction? Next topic that comes to our mind, what causes friction? So look, at microscopic level, all surfaces are very irregular. At microscopic level, all surfaces are very irregular. So when two surfaces are in contact, there are certain points where the two surfaces are in actual contact. At other points, they are not in actual contact. At certain point only, they are in actual contact. At the point of actual contact, atoms come very close to each other. An electromagnetic bond will be formed at those points, and due to the electromagnetic bond, if the upper surface tries to slide over the lower surface, there is a force that opposes this sliding. For upper surface to slide over the lower surface, the force applied must be enough to break all these bonds, all these electromagnetic bonds formed at these points. Got it? And one more thing we can note, that the strength of the bond depends on the normal contact force between the two surfaces. This depends on normal contact force between the two surfaces, not the area of contact. Because if the normal contact force is larger, the bond strength will be larger, and larger force will be required to break the bonds. Larger force will be required to break the bonds. Got it? We can see this from an example. Let's say we have a plain wooden plank. Another, we have a heavy wooden table. Obviously, wooden table has less area of contact than this wooden plank. Okay, and if we pull, this is light. Keep in mind, this is light wooden slab, and this is heavy wooden table. It has large area of contact. This one has a small area of contact. We apply some force on both, on the table as well as on the plank. So what we find, let's say F1 force is required to pull this slab and F2 force is required to pull this table. And what we find, that F2 is greater than F1. F2 is greater than F1, and Look, one more thing we can see, that this has a small area of contact and this has large area of contact. So even this slab has large area of contact, but still it requires less force to slide. But this table requires larger force to slide on the surface. So from this observation, from this we can say that friction is independent of area of contact. What we can say? Friction is independent of area of contact, and it depends on the normal contact force between the two surfaces. And here clearly the normal contact force is related to the weight of the two bodies, and obviously table is heavier than this wooden slab. So normal contact force in this case will be more than the normal contact force in this case, right? So we are getting very important point, that friction is independent of area of contact and it depends on the normal contact force between two surfaces. Now we are talking about variety of friction. The first is sliding friction. Second, rolling friction. And third, this is viscous or drag force. We will discuss broadly about sliding friction and then we will talk about rolling friction. Sliding friction acts when two surfaces slips over each other, or they tend to slip over one another. Either they slip over each other or they tend to slip over each other, then the friction involved is said to be sliding friction. Rolling friction acts when an object rolls over the surface of another body. And viscous or drag force. This force is involved between the layers of fluid or between fluids and solids. So now we are going to talk about sliding friction. Sliding friction is of three types. First is a static friction. Second is limiting friction. Then we will talk about limiting friction. And then the last one is called dynamic friction or kinetic friction. So first we are going to talk about static friction. Static friction. What is a static friction? Let's assume that there is a huge block and I am pushing the block, but the block doesn't move. So where does the effort I am making goes? I am pushing the block doesn't move. Where does the effort I am making goes? Basically it is counterbalanced by the friction, and that friction is called static friction. Let's say Let's look at this example. This is the block and we are pushing the block. Let's say we are applying a force of capital F, and now this block remains stationary. This block remains stationary or at rest. So where does this force goes? What happens to our effort which we are making? So basically this effort is counterbalanced by a friction which is called static friction, and a static friction obviously must work in the opposite direction of the external force to counterbalance the external force which we are applying, right? Let's say if we are applying a force of 1 Newton, the static friction must act in the opposite direction and having magnitude of 1 Newton. Let's look at another example. Let's say we have increased the force from 1 Newton to 2 Newton. The static friction must be of 2 Newton in the opposite direction, right? So likewise, if we are increasing the force, external force, static friction also increases. Static friction also increases. So first let's define what is a static friction. So static friction is a force that opposes the tendency of relative motion. Static friction is the friction that opposes the tendency of relative motion, because if we are applying some force, this block will tend to move, but static friction is countering this force so that it can't move. So as long as this block remains stationary, static friction will act. Once it started moving, static friction will be disappeared and another friction will act, that is called dynamic friction. Right? So look, we are talking about static friction, which is a force, and force has two things. First is direction and the another is magnitude. So first we will talk about magnitude of static friction. Magnitude of static friction. See, static friction is a self-adjustable force. Self-adjustable force. What it means? Self-adjustable force means its value adjusts according to the external force we have applied. Let's say we have applied a force, external force of 3 Newton, but the block remains stationary. Block remains stationary. From Newton's first law of motion, we can say if block is stationary, net force on the block must be 0, isn't it? Net force on the block must be 0, isn't it? So if net force is 0, means there must be a force which is counterbalancing the external force of 3 Newton. So the static friction must be equal to 3 Newton in the backward direction. Static friction must be equal to 3 Newton in the backward direction, right? So magnitude of static friction is equal to the magnitude of external force we are applying as long as static friction is acting on the body. Alright, so next we talk about direction of static friction. Static friction always acts in the direction so as to oppose the tendency of relative motion. Is so as to oppose the tendency of relative motion. direction of static friction is so as to oppose the tendency of relative motion. For example, let's say this is a block, we are applying a force F in the forward direction and the block is stationary. So from Newton's first law, net force on the block must be 0. Net force on the block must be 0, and F net to be 0, the static friction must act in the backward direction. So static friction here is opposite to the external force we have applied. Let's take few more examples related to the static friction. Let's say there are two blocks kept one over the other. Let's say this is A, this is B, and force is being applied on the lower block. And both blocks are moving together. We also assume both are moving together. If both the blocks are moving together, then block B will be stationary with respect to the block A. Look, the external force F is accelerating the block A and block B is also simultaneously accelerating. So which force accelerates the block B? How is it possible to accelerate a body without any force? It is impossible. So there must be some force, and this force is the static friction which acts in the forward direction. So static friction must act in the forward direction on the block B, right? And from Newton's third law, we can say the static friction on the block A must be in the backward direction from the Newton's third law. Okay, so this way we can find out the direction of static friction. Right. Let's take another example. This is block A, we have another block B, and this time external force is being applied on the block B and both blocks are moving together. Both are moving together. Right. So both are accelerating in the forward direction. Again, if you look, we are not applying any force on the block A. So how can it accelerate without any external force? It is impossible. So for block A to accelerate in the forward direction, there must be a force which is the static friction, obviously static friction. So static direction of static friction on the block A must be in the forward direction so as to accelerate the block A. And for block B, from Newton's third law, static friction must be in the backward direction. So in this way, we can write the direction of static friction on a body. We can take another example. Let's say this time we have three blocks, block A, B and C, and external force is being applied on the block B, and all the blocks are moving together. Accelerating together. So now again we can say for block A to accelerate, there must be an external force, and this force must be static friction. So static friction on block A must be in the forward direction. Let's say this F1. So according to Newton's third law, static friction between A and B on the block B must be in the backward direction. Likewise, static friction on the block C must be in the forward direction. Let's say F2, because without any external force C can't accelerate, and since C is accelerating, there must be an external force, and this external force must be in the forward direction, and this will be F2 in the forward direction. And from Newton's third law, on F2, static friction F2 must be in the backward direction. So this way we can represent the direction of static friction on block A, B and C.